function as it approaches a certain constant on a graph. Okay, so remember that f of x here is an equation of this piecewise, which we don't know. Of course, we can verify that if we would rigorously find the equation of this piecewise, but we're not after that. We're trying to find the limits of a function. Now, remember, the limit exists if from the right and left of the function, okay, coming from a certain constant x, they will approach the same value of y. If it's different, therefore, the limit will not be existing. So we should have a particular value of y that could approach your values from x from left and right. So let's go first with limits of f of x as x approaches 2. So our 2 is here, all right? So we are referring to this graph. Now from the right, your y is approaching negative 2, negative 1, I'm sorry. And from the left, okay, as x approaches 2, it approaches also negative 1. Notice that it is a whole. Here you might be thinking, the limit does not exist. No, it's not like that. Okay, we are only trying to find out what is the function is approaching as your x is approaching positive 2. We are not specifically trying to find out the exact value of y. So therefore, the answer here is negative 1 is because from the right of 2, your y is approaching negative 1, and from the left of 2, your y is also approaching negative 1. They should be the same. Now let's go to number 2. So, what is the limit of f of x as x approaches 5? So, as x approaches 5, we mean this x, and therefore, it refers to this graph. So, from the right of this graph, your y will approach negative 4. Notice that I'm not going to choose this dot, all right, because this is a removable discontinuity. All right, so it means that there is a break here. Your y here from the right of 5 will be approaching negative 4. And from the left, we mean this graph, it will also approach negative 4. So we are very particular at the hole and the dots or any black points of the graph where your x will be approaching. So it will stop here, but it's gonna continue here, and from the left it will also approach negative 4. Since the limit from left and right of 5 is the same, which is negative 4, the limit is existing at negative 4. Okay? Now let's go to number 3. Now this is really very specific because there's no removable discontinuity in this graph. So from the right of negative 6, so because negative 6 is here, we are referring to this graph. So from the right of negative 6, your y is approaching 2. And from the left of negative 6, it will also approach 2. So therefore, because the left and right hand limit are the same, at 2, the limit is existing at positive 2. Now let's go to number 4. Okay, as x approaches 4. So we mean this value, all right? So therefore, it covers two graphs, this graph and this graph. But as you can see, there is a jump discontinuity here. So you might be thinking, it should, the limit here is not existing because there's a jump discontinuity. Why? It's because from the right of 4, okay, your y is approaching negative 5. Now, we have to consider this gap here because we are coming from the right. There is a pause here, but there's a dot here. So, therefore, this will be referring to negative 5 as x is approaching positive 4. Okay? But from this graph, as x is approaching positive 4, okay, it approaches negative 2. So the limits are different. From the right is negative 5 and from the left is negative 2. So therefore, the limit of f of x does not exist. And this is the symbol for that. So remember, for the limit to exist, the left and right hand limits should be the same. If the left and right hand limits are not the same, the limit will not be existing. And of course, the limit doesn't have to be a dot. It could be a hole where your x is approaching from left and right.